Okay, welcome to this our first webinar on the smart solutioning theme. It is actually a webinar designed mainly for our Capstone students, and we really hope that this there will be next episodes of these webinar that will give more information to the Capstone students, potential one, as well as maybe even the associates to think about what is the trends and how we can formulate projects for such themes. So today, to kick off our this series, we have invited Mr. Darwin Goshawk, who is actually has a very unique background. I will let him introduce himself later on. But now he's actually a true participant in this IoT revolution here locally in Singapore and very close to us. So we are very glad that we have the chance to hear first-hand experience from such a person. So the topic is the what and how of smart connected systems, and there will be some case study on a particular platform that he will introduce, and hopefully that will allow many of us to get on with IoT or smart connected system development. So without further ado, I would like to welcome Darwin Goshawk, and then I will pass the mic to the speaker as well. Thank you. So Darwin, yeah, here you go.
Thank you very much, Paul, and yes, such a kind word from you. And thank you for the privilege of delivering this webinar to all of you. So just to follow up with what Paul has said, let me just introduce a little bit about myself. So right now, I'm the founder of this company called CryoWorks. It is a retail automation company that brings IoT solution to brick and mortars. I will talk a little bit more about that later when we showcase some of the examples of how IoT used in a retail scenario. Before I started CryoWorks early last year, I was working for NUS for over a decade, and with my last position as a head of IT services for Yale and US College. So I've had experience with the cloud computing, architecting hybrid clouds, and cybersecurity throughout my career in the US. And before that, also in the US, I wasn't a graduate of a computer science degree. I'm a graduate of physics, and my area of research after I graduated was in the area of quantum cryptography and quantum computing. So that is completely another topic. So that's who I am, and today I'd like to talk something close to my heart, things that I've been working for the past 1 year plus. Basically, something that the media and the people have been talking about, the Internet of Things. And what is that? So first of all, let's just think of things itself. So what are things? Look around you. On your table, what do you have? I have a cup. You might have a glasses. You might have a guitar next to you. Those are things. So things are the things that we use on a daily basis, a real physical objects that is useful in our life. Now, the idea of Internet of Things is we'll see how is these things are connected to the Internet. But let's just take one example of thing. Tractor. Okay. Before tractors came about, we use animal. Could be horse, cow, any other kind of big animals to plow the field in the farming scenario. So A tractor itself is already a step upgrade from an animal, and there is a lot of machinery, and it's pretty sophisticated on its own right. Okay, there is a lot of modern tractors have a lot of electronics that is combined with the old invention of motors and engines that we had before the era of electronics. But we still don't call these tractors smart yet, when it's just motors and gasoline goes around to power up the tractors. What makes a tractor smart is when the tractor itself has some sort of sensors built in. For example, let's say you put a sensors on the vehicles to see the density of the soil that is on, or the humidity of the soils, and the hardness of the ground, and adjust some of the parameters on your plows or on the traction of your wheels. So it means that a tractor becomes smart when you have a combination of sensors and actuators on it. So this way, suddenly you say, hey, I have something smart. And this smart tractors might have a dashboard that could be on the tractor itself, showing you what it is on the field. So what make things smart? Basically, the first thing is that it is able to monitor. The monitoring through use of sensors to give you an alert or to notify you when there's any changes. And if you have actuators combined to it, and you can control the product, the product here is a tractors, then the second layer built on the monitoring is the ability of a control. So once you're able to monitor and control, then you think of it, hey, can I just write an algorithm if this, then that? So if I see a ground of harder ground, then I'll put more strength on my plow. And that is where the optimizations came in, where you can enhance the product performance and give you a predictive diagnostic as well. So for example, let's say the tire of the tractors, you have a sensor to see how much it has worn off, and basically give a predictive diagnostic to say that, okay, we say that in the next month you need to change the tire. The next step, that once you have this capability, the next ability is that you can bring autonomy on the product itself. So a smart autonomy, for example, it could be self-driving, or it could coordinate with other tractors, for example, tractors using for plowing. So you basically say, okay, these 4 tractors, let's do it. They can agree on their own. I will do this part of the field, and another tractor will do another part of the field. Self-coordination. Self-diagnosis and repair. Minor thing, it might be able to repair by itself, or diagnosis reporting to the manufacturers, to the back end, to be able to repair. So I said connected just now. When you have a smart tractor, the smart tractor itself need not to be connected. The whole intelligence could be possible within the tractor itself. However, as you see, especially on the capability on the that we see earlier on the self-organizing, there is an advantage of a tractors to be able to talk to the other tractors or talk to the back end. For example, when the tire is worn off, it is sort of useful to tell the farmers that, hey, you need to change the tire next month. So wouldn't be useful that the tractor itself tell the distributor or the supplier of the tractors to say, hey, deliver a replacement tire next month. And for that, you require the tractor itself able to connect to something or somewhere. So one of the obvious connections, especially for within self-enclosed farms, is to have a server where it reports back the information that it gathers on the field, the soil hardness and all this information. But coordinating everything onto a local server, it's not necessarily the best thing to do. All right, I'll tell you why. So let's just take a step back from the field and look at the waves of IT, of how it has drive transformation. In the beginnings, when we have this whole IT revolution, we have computers. So the computers have to automate activities. For example, we do have POS system. Okay, in the shops, it helps to automate to know, okay, what is the sales of the day. You might have Excel sheets that helps you to tabulate your spreadsheet, or you have CAD/CAM applications to help you to automate part of your drawing or drafting process. And the next transformation, actually, when the internet comes about, it's pretty near to each other. The internet allows that all these activities that individual people do on the computer to be coordinated in a larger global scale. So, but usually a lot of these activities, most of the economic activities that we do is to produce a product. So, for example, you want to produce a book. So in the computer world, the computer helps you with the word processors, like Microsoft Word. It helps you to make your copywriting process to be more efficient, productive. And on the internet age, you are able to collaborate with other people to, for example, proofread your documents. But the next stage is the IoT. The IoT, unlike the computer and the internet era, it is not about coordinating activities, automating activities to produce a product, but it is bringing the IT itself to the product. Maybe, for example, a smart book, a book that, for example, without a bookmark, a physical book that will tell you, okay, this is where the last place that you read. Or maybe a book that will able to, for example, it's a school textbook that will be able to track your learning progress and share it with your friends or with the school about your learning process. Or the scribble that you write on a physical book get translated into a file or into a learning management system. That is some possibility. So the next revolution of the IT is where the IT itself is become part of the product. So where am I getting at? So as you see just now, the smart tractors, while the tractors itself can talk to the servers, the intelligence is going to be very limited if it's just about coordinating the tractors itself. But what's going to be useful is it connects to the entire internet, where we bring the machine-to-machine communications into the real true Internet of Things. Here's what I meant. So the tractor itself might communicate with other machines through a farm equipment system. It could be local within the farm itself. We might have a server to coordinate the other equipment that you have in the farm. But the farm itself contains more things. You can do a weather data system. You might have a seed optimization system. You might have an irrigation system. And the seed optimization system, like the seed database, might not be in the farm. It might be on the other parts of the world. The weather system could fetch data from the satellites. The irrigation nodes might work together with your irrigation system that is probably done by the third party. So Internet, which is a global network that connects different kinds of systems, it is perfect to connect all sort of the different kind of systems to work together. And this is where the IoT excels, where we bring the next step of a machine to machine as ingredients to Internet of Things. So what we can see here in the Internet of Things, the architectures usually comprise of three parts. First, you have the products. The product could be a tractor, could be a pen, could be a cup, anything basically. And the thing itself has DIT component. It is most likely a small embedded system. Even and there's a hardware to it, like microchips, and then there's a software to it. And these things need to communicate out. So it means there is a need of connectivity. Okay? The connectivity could be product to products, or if they would like to gain more intelligence or more coordination, it can connect to a computer system that resides on the cloud. So the cloud, where you can run the heavy-duty applications, but not only that, the great thing about having it as a cloud, you can have it as a place where you collect information from different products that you have and run analytics on top of it. Okay? So you can find a macro patterns of the products that might not be, you might not be able to find the pattern just on the product sensor itself. And furthermore, you can have this thing as a platform to connect to other kind of system to enhance the experience. So, for example, just now that we see on the earlier slide, a farm systems would have a benefit when you're able to connect to the weather system, weather platforms. All right, so I mentioned about cloud and I mentioned about data. So while the world of IoT is itself starting from the world of hardware, there's another revolution that come together or works together and basically made together with the world of IoT. And these are the world of cloud computing and the big data. The cloud computing and big data are not necessarily has to go along with the IoT. But generally, IoT, when it's scaled to the massive scale, requires these two. So as I said earlier, a single tractor might not produce a lot of data, but when you have a big corporation with the tractors that collecting continuous data, you require a backend that is able to grow elastically to your demands of your production. And that is where the cloud computing is coming in. And not only that, as your data progress further and your IoT devices getting more sophisticated, collecting more and more data, suddenly you will face with the data explosion. Not only that you are challenged with the how to store this data, but how to process this information to gain insight. So this is where the big data tools and the data science comes in place. In this course, we will touch this at a very basic level because the whole world of big data and data science, as well as the cloud computing, is it could be a separate field on its own. So this is just to let you know, but where IoT could be very strongly correlated with these two other areas as well. So to get started in IoT, now if you want to do IoT, there's a hard way of doing it or there's an easy way of doing it. A lot of people that the hardcore developers probably will go through a very basic protocols and build it from the ground up. But the thing is that there's a lot of system out there to allow you to rapidly prototype, and even if you have an IoT solution that don't really need to scale to the global level, can be done pretty quickly and easily through these IoT platforms. So in this course later, I will introduce one of the tools that the university will use to allow people without a programming background to enter the world of IoT, and that is ThinkWorks. We will not. We will go through ThinkWorks later part of these lectures. All right. So we have seen one particular use case of IoT in the field of agriculture, which is a tractor. But we can see a lot more use cases of IoT. McKinsey actually identified the 9 different major settings for the uses of IoT. You use it for home, offices, factories, retail environments, work sites, on the human itself, on our body, for example, outside environment, cities, as well as within the vehicles. So the example of that we gave just now, to a certain extent, this is a vehicle type of environment. So let's just see other kind of use cases. Factory or warehouse, something that is done repetitively. So this one is a Kiva robot. The robot is the things at the bottom, the orange color things. So what is this Kiva robot? Kiva is one of the companies that is, a couple of years ago was acquired by Amazon. What happens in the past, when you have a warehouse, you have all the items stored in the big part of the warehouses, and you usually organize. You have a rack for the books on economy. You have another rack for cereal. You have another rack for something else. But the way that Amazon do on the warehouse is very interesting. And what happened is that, first of all, in terms of item storage, they put items on a very random basis. And they store it all in the database of where is where. And they have these robots to basically bring the shelf itself. So now, instead of the human that figuring out where are the items, when there is an order came in, the Kiva robot will pick up the nearest shelf, the nearest rack that have an item to be packed. So the item packers will sit in their station, and all this Kiva robot keep coming and bringing the appropriate shelf for them to pack. This enhance the packing speed so that they can process more orders per unit time. So this is one example of IoT. The whole entire information from the customer orders goes to the robots. The robot itself checks with the backend warehouse management system to figure out which items are on which shelf and where they are the shelf, and bring them up. Another example in the context of cities. So this is one of the projects that currently Singapore embarking, which is a smart lamppost. You can think of a lamppost as a ubiquitous thing, but a lamppost could act as a marking or basically a landmark in the city. If you notice, for example, all the lampposts in Singapore, they all have a unique serial number. So, for example, when you are stranded in a very long highway, and usually you would like to call LTA or someone to pick up your breakdown car, you can actually quote the lamppost numbers and they know where you are. So lamppost, even the most traditional lamppost without smart features, already act as a way of bringing smartness into the into the entire nations. What if we do more? What if the lamppost itself could be a beacon, could be a sensor for traffic? For example, you put a camera on top of it. It could be used for transmitting data as well. It could be used as a way of autonomous cars to gauge where they are. It could be a sort of a GPS that is offline, because you see, when you use a GPS, you need line of sight with the satellites. But what if your car inside a tunnel? So let's say the tunnel have of course, on the tunnels you need to have a light. The lights on the tunnel itself could be used as a geolocation internally within the tunnels. So the Singapore government has been embarking to see how the lampposts could be used for the city infrastructures to imbue smartness in the cities. Another thing that you can embed within the sensors here, for example, rains, so that you know which part of the city has rain, humidity, pollution sensors, and so on and so forth. Next example, in the retail scenario, and this is a topic that is close to my heart because this is a startup that I do. So let me try to elaborate a little bit of what my company do. So what my company do is trying to address the issue that Singapore face with the crunch of the manpower. As you see, in the Singapore context, we are trying to reduce the reliance on the unskilled foreign workers. Okay, and one of the things that one of the areas that use a lot of unskilled foreign workers is in some of the service retails, for example, cashiering. All right, so with the crunch of manpower, there is a demand and requirement of seeing how we can automate the retail experience, but yet retaining the brick and mortar fields. It is true that you can sell a lot of things on the normal vending machine, but you will lose the retail experience by touching and choosing the items that you like in the normal brick and mortar shops. So one of the things that I'd like you to Google after the course is to try to see Amazon Go. There's a retail concept shops by Amazon. It's not open for the public yet. But what the Amazon Go try to do is showing the future of supermarket, where one, go into the supermarket with the mobile apps, pick any items that you like. When you go out, it will be charged to your credit card automatically. So what we do at the Fireworks is something similar. So we have a display cabinet. For example, in this picture is a chiller, where customer could scan, take what they like, and when they close it, it will be just to their credit card. So no cashiers. The IoT allows inventory at the back end to know when and what to replenish. All right, moving on. Another use case scenario is on the human itself. So maybe some of you already have Fitbits. The Fitbit itself is an IoT. Yes, granted the Fitbit itself, right now most of it do not talk to the internet directly, but they usually do it via your mobile phones. So the Fitbit itself is equipped with a lot of sensors, measure your heartbeat, respiration, and other vital signs. All these things could be useful for you to understand about your health and may be able to take actions for it as well. Next, outside. So another example is the self-driving trucks. The self-driving trucks will be able to optimize logistics tremendously, because now, when you have a different trucks communicating to one another and optimizing their logistics without the need of manpower to drive it, suddenly you have improve of productivity in the logistic world. And improvement in logistics always reduce product costs as well at the end of the day. The work tracks, as we have shown just now, the pictures of the tractors that I shown earlier is a tractors made by this company John Deere, which is one of the US companies that have embraced strongly on IoT in the farming sectors. A lot of the trucks actually communicate back to the backend, to the internet, to equip with a lot of sensors to know what kind of soil condition they can map and optimize the system accordingly. So a lot of things that I use is vehicles, but specifically inside the vehicle itself, the Tesla, for example, have a lot of internal sensors to basically self-diagnose and able to upgrade and let the customers know when to change their tires or when to change the oils. Okay. The next context is in the home automation. In the home automation, we have an example here of Philip Hue, where you can automate the lighting of your house to suit a particular ambience, whether it's for study, party, or movie watching. All these smart light bulbs are controllable via mobile apps. Another example in the office context, of course, some of these equipment actually being used for home as well. There's other players outside of Nest, such as Honeywell. There's a lot of IoT automation came in the world of HVAC and the security. So now the CCTV in the offices are no longer just being watched by security guards, but connect to the backend system with the machine learning and artificial intelligence to understand the people who goes there. For example, facial recognitions to see whether the people who goes in are the staff, or for example, if you do it in the retail setting, it could be used for detecting theft or understanding the footfall into your shops. So there's a lot of a settings where one can use IoT devices. So those are the 9 settings of where how IoT can be used. So the IoT equipment itself tends to be able to be used in many sectors. For example, just now, and if you have a particular sensors, it could be used in many settings. So it seems that it is probably, you said it's difficult to start an IoT. It is true that maybe it's difficult to make an IoT devices or an IoT sensors, but a lot of times the IoT innovation is not necessarily only on the making of the sensors or the devices. A lot of times is the system integration of what is available and make things work together. And for that, you don't actually really need a very so-called deep engineering or deep knowledge on science, physics, or computer science. To integrate this thing and create innovative solutions, there are tools out there, for example, like ThinkWorks, to allow even non-programmer to start getting started on IoT. So here's what I'm going to do to show how one could create a mashup of data and visualization using a ThinkWorks even without the need of programming. Okay, so ThinkWorks itself has done amazing tutorial and workshops on how ThingWorks works. Okay, and let me just show you this video made by them to show how the messed up components are being made, creating them, the messed up stuff, and at the end of it, how do you bind them to services. So I'm going to play some YouTube video, and when the YouTube video plays, I will mute my mic to prevent echo, and I would recommend you to click theater mode so that the quality of the video is going to be better for you, and you'll be able to see the video clearly. So let me just go into the first component of a messed up component. Give me a minute to wait. All right. So if you have any questions along the way, just feel free to post it on the chat while the video is playing. Okay.
Hi everybody.
Okay, so on the video itself, you see that the component is usually made mostly clicks and typing. There is no code involved. But what happens there is, if you have a programming background, this is basically just creating a project scaffolding, okay, and to allow associations of different kind of objects to be gathered together. So I'll show you the second videos of creating the actual object itself. They call it the mess up, the components, and I'll go to the next one. All right, so you see on the second video how they make the user interface and that needed for the next step. So the first components, the first video, they make all the scaffolding and some of the basic components. The second part, basically, is a quick way of making a front end or user interface without learning how to code in HTML or CSS or JavaScript. Okay, so the next video is going to show you how they're going to mess up, basically the term is how they combine these components with the user interface together. All right, so let's just move to the next video. Okay, I hope that is useful. So for any of you that have done programming before, web development, maybe this is very basic, but what we are trying to show here is that you can do these things without necessarily a knowledge of programming. Okay, with the tools like ThingWorks, some of these things could be actually connected with actual sensors. Okay, where we could have actual hardware like Raspberry Pi, BeagleBones, Arduinos, and other stuff that will fed the data into the ThingWorks. And for example, let's say the temperature. So we can have a temperature sensors that will move the gods in that temperature gods. So what tools you will use exactly for your capstone projects will depend on your background, what you're familiar with. Don't worry if you don't have a programming background. We can use ThingWorks or ILA. if you have stronger programming backgrounds, we may want to try something else. So let's move on to the Capstone projects and how we can do IoT for your Capstone projects. So for the Capstone project, we have 3 projects that we will offer in this for you to choose. And if you have any questions regarding any of these 3 projects, I do believe we have some of the other supervisors, because I will be the co-supervisors bringing in the insight on the IoT hardware part, but there will be other lecturers that is going to bring in their expertise in this specific domain, the domain expertise. So the first one is how to apply IoT in the smart retailing. Okay, how to see, how to engage the customers, how to see the customer engagement. For example, let's say it's a retail shops. What are the items that they browse, they took, they see, how long they spend on each of the aisles. Okay, it could be also, for example, let's say when the customers usually always buy some things, but they say that you see that, hey, they come and they forgot to get something. How can you tell them that, hey, you might forgot to get something? Okay, so a lot of this smart retailing will do help in terms of either reducing operational costs or increasing the revenue through engaging the users and cross-selling and upselling the products. So that is smart retailing, how you enhance customer experience. The next is on the topic of a smart home. So home is one of the settings or area where there's a lot of talks of use of IoT. Just now we have seen Philip Hue, we have seen Nest have the thermostats as well as smoke detectors. A lot of some of the washing machines these days are very smart. They will be able to tell you that the washing cycle has completed. Okay. The TV, the blinds that adjust basically to adjust the light levels that goes into to your house, to your homes. Okay, so all these things. Now this project is basically how do you combine all these things to make it truly smart? Because a lot of these components usually they work independently on their own, and maybe one of the things that we would like to explore with the smart home is to create a dashboard to basically control all these different parts of the smart home components that might control a different component of your homes. All right. The last part of proposed projects is on learning live stream. I believe most of you are using Facebook. So in the Facebook, you do streams a lot of your live parts. For example, what you eat, things that you just newly bought. For example, you just have a new bike, and you just tell people, hey, I have a new bike. Oh, hey, I traveled how much and exercise how much using your Fitbit. A lot of part of your life, you actually stream it through the social media such as Facebook. Maybe we can do the same thing for our learning, and we could potentially tie it to smart devices. For example, maybe a Fitbit, you indicate to your Fitbit what's your heartbeat during this particular study times, so that you can see, oh, okay, when I'm calm, I learn more, or some things like that. And you can, when you achieve something, you finish a particular assignment, you would like to post it as part of your learning live streams. Or every time you open the books, you might do a stream say, I am starting to learn, open chapter 2 of the IoT, Guidance Guide to IoT, or whatever. So this is one of the things that where we can try to see how we can imbue IoT in the physical things that you have, be it the mobile phone, the books, or even the Fitbits, in the process of monitoring and understanding your learning habits, and see how you can improve your learning. All right, so some of the materials that you can see more from what I've talked today. There's this articles on the HBR, Harvard Business Review, as well as there's this, the second link is McKinsey report. And there's a third link, if you'd like to know more about ThinkWorks, okay? There will be materials there on that third links. All right. So I'm trying to open for Q&A here, and what I will do here, you can type the questions in the link. At the end of after the Q&A, what I will do is that I will give you the link to download my my presentation slides, which you can download. But I will enable a mic for everyone, so that if you have a question, you can ask using a mic, or you can type it on the chat room. Okay. So if you have any specific question on the project itself, some of the project co-supervisor is here in the room. They'll be able to explain as well further about the project. Okay, we have 15 minutes on the Q&A sessions. I'm open for questions if there are any students right now in the room.
Okay, maybe maybe I can jump in. Can you hear?
Yes, I can hear.
Oh, okay. Yeah, so just now, I think the demonstration of the mashup involving the 3 steps, I guess one of the questions we may have, not particularly, not shown in the demo, is how the connectivity to the sensors and the edge is going to be done in ThinkWorks. I think you mentioned that the application can actually connect. Maybe you can talk a little bit about what's the connectivity components of that, extending the demo. Just explain what kind of technology may be used or what protocol is used typically in the IoT connectivities. Yeah, thank you.
All right. So in the IoT connectivity, there's different kind of components. It really depends how much capable the hardware, because your use case scenario and settings are very different. And if you have a relatively capable gateway or relatively capable so-called embedded systems to communicate with the back, usually they will try to communicate via HTTP protocols. There is the web basically, and usually the information are being passed around through an API gateway with payload, or the data being transferred usually in a JSON format, JavaScript objects. However, there are scenarios where you might work with somewhat more lightweight systems. So there are protocols used, for example, like MQTT that will connect to the backend. And if, for example, you like to connect your mobile phone itself, because mobile phone contain a lot of sensors, gyroscopes, and accelerometer, and etc. The nice thing is that ThinkWorks has a specific app that you can have it installed on your phone, like Android phone. You can use it to collect data and submit to the backend. So in that way, you don't really need to write a lot. So the ThinkWorks have a number of modules that you can just download and install on Raspberry Pi and Arduino to allow connecting all these devices without writing similar code. Usually, a lot of the devices that work almost immediately with ThinkWorks are a system that has a relatively high-end MCU or microcontroller unit. However, if you're working with raw devices, raw MCU or sensors, that is going to be something that where you need level programming probably to connect to the backend. So it really depends on your background, and ThinkWorks great for some quick prototyping, and a lot of they have made modules in many different kinds of IoT kits already available, such as Galileo, Raspberry Pi, Arduinos. So as long as we stick with some of these relatively capable IoT kits, it should be pretty quick and straightforward.
Well, thanks. Maybe you can, because you're vending just a bit of marketing your own product. How is this connected to the backend? if you don't mind sharing, yeah.
Sure, no problem. So first of all, there are a couple of things on my product that I'll just probably show a little bit. Okay, here's there are two things that you can see here. One is the phone of the user. Another one is the chiller. And the third component that you don't see, and most in the IoT scenario that you don't see, is the backend in the cloud. If you use ThinkWorks, the ThinkWorks is going to be the backend. So one of the misconceptions that some of the people that see our system is that they thought the phone is talking to the smart chiller. Okay, the phone itself does not communicate with the smart chiller. It is possible to do that. So some of the phone have NFC, some of the phone have Bluetooth LE. But the thing is that when we are trying to deploy IoT solution, especially in the consumer, I need to see what is the most common denominators. Not all phones have NFC, not all phones have Bluetooth. But most phones have a camera, at least smartphones have a camera. Okay? So what we do here is that we put a QR code. And the QR code is nothing smart. It's not cheap. It's basically an address, a URL, which indicates the chiller number. Because when you scan, you need to know which chiller you like to open. So the apps that I make communicate to the backend. Because the phone is capable, we'll basically do HTTP connection to pass JSON payload. And that phone will authenticate to the backend and say, hey, I'm Darwin. Can I open this fridge number 2? And the backend will say, okay, Darwin, do I have your information? I have your information. I have your credit card information. And you seems to be a good customer. Okay, fine. Let me see whether this fridge is a fridge 2 that you would like to open. It's a valid fridge. It is a valid fridge. It is operational. Okay, let me send a command to open. And the backend will send an MQTT command to the chiller. Why MQTT? Because the hardware is limited in terms of what it can do, because we are using a TRR spec for that. So now, once the chiller is successfully unlocked, is sent back to the cloud, say that, okay, I have opened the door, and the cloud backend will send back to the app, say the door has opened. And now the customer able to see the price menu of what is inside the chiller, and the price is updated to as the time they open. Okay, and they are now able to inspect the items. They can pick it up physically, see what they like, compare, see more information on the app itself, because the app will provide more further information. As it closes, the chiller have a sensor to detect that the door has locked, and that triggers a further mechanism to basically sense internally what has been missing. So now the chiller will send back to that backend cloud, these items has been taken, and the backend cloud will basically say, okay, here's the amount that has been taken, here's the amount that I need to charge. And because the backend is a platform, it communicates with another system, which is a payment gateway, not maintained by us, maintained by someone else, to charge the credit card of the users. And when that gateway is report successful, we'll tell the user and send a receipt. Your payment has been processed. Enjoy your meals. So the great thing, the most time-consuming of this whole process usually is building the system to communicate back the hardware, the apps, and the backend. So in order to shortcut a lot of these things, usually what happens is that instead of building a smart, like for example for our case, a smart chillers on your own, you can use smart things that is already available. For example, Philips Hue light bulbs or other kind of systems. And the app itself, you can use rapid prototyping. The ThingWorks allow some rapid prototyping on the apps, or you can use other apps such as PhoneGap to do that. And the backend itself, to allow you to do a rapid prototyping, you can use things like ThingWorks. I don't know whether I can replicate what I do here, everything on a ThingWorks platform, but that's not what I do. But certainly there is a lot of things that you can do with the ThingWorks. But once you are going into your own IoT solutions, it is inevitable that you will try to reduce costs by using the raw MCU, building your own PCB, building your own apps to ensure scalability to the global level, and do it at a cheap price.
Well, thank you very much. Any other questions from our colleagues and participants? Only 4 minutes left.
Just now, earlier during the early part of the webinar, someone asked, how can we make airports smarter? I can't think of how to do it smarter in the runway, but there are many ways that you can do smarter, for example, on the transit terminals. For example, you can have SMS broadcasting or Bluetooth broadcasting or other way to inform customers when there is change of gates. Okay? That happens. So you don't want customers to be late because of there is a change of gates. And you'll be able to find when the customer is wrong, maybe through using Bluetooth LE as a beacon. You have a particular beacon to help guide users to go to particularly where they want. Okay, and a lot of times the airport announcement system might do in 2 or 3 languages, but internationally people speak many languages. Maybe one could do the announcement systems through the apps to hundreds of languages depending on what languages they like to do. And we can always automate some of these things through the cloud services such as language translation service. So there are many ways that we can do that. So with the help of IoT and the cloud backend to make experience in different kind of settings to be much more enjoyable and productive.
Thanks again. Maybe just one, because we have 2 minutes left, I will fill in the question regarding this airport things coming based on my understanding of the there's actually maybe because maintenance-wise, I mean, actually just now what you mentioned is more like airport facility management or the airport itself. But how about the aircraft maintenance itself? Have you thought about that part of the issues? I mean, but okay, I think that part concerns the domain knowledge. So I think that's where just now Dr. He mentioned, you know, he's the area expert in that area. Yeah. Sorry. Yep. Go ahead.
I think on that part, as far as I understand it, because I have one engineer which is actually from aerospace, a lot of the modern component of modern aerospace itself is already IoT. Most of the aeroplanes are already connected to satellite to sense their telemetry, and the component itself have internal sensors to know when it's being wear off and stuff like that. In fact, as yesterday I just been told that Rolls-Royce also, because of the model that they do right now with this system, they are not just selling their jet engine, like, okay, here's the jet engine, buy it a few $1 million. They can charge it per kilometers travel in the air. So, and then basically they provide the whole maintenance and stuff like that. And they know how long, how much is being used because they have all the telemetry information, the IoT data from it. So I don't claim a full knowledge on that, but what I know is the people behind the Airbus, Boeing, Rolls-Royce, they have done a lot of IoT in terms of their equipment and their spare parts. Any other questions? No? So it's 11:31. So Paul, how would you like to wrap this up? Will someone stop the recording or?